Hi everyone. Today I'm going to talk about the enterprise data landscape journey as how it all started around 20 years back and what shape currently it is now. There are a lot of changes that happened in the data area for the last couple of years, and anyone joining new to this field find themselves extremely confused about different jargons, different tools and the requirements. It is really getting extremely hard to fulfill a data requirement by looking at the customer job description, mainly because we look for the words without understanding the meaning behind them. It is really no mistake of someone who joined a few years back and understands it, because data world currently is a collective ecosystem of tools, technology which are developed over 20 years. And any enterprise currently having data platform which are mixed up of tools developed in the last 20 years. My main motive here is to tell you all to explain how it all started 2 decades back and what changes happened over the time and where the data world currently stays in. So overall, we can consider data journey into three major divisions. Remember, these are not three versions where a new version discards the old ones, but they are three evolution of data field, and they carry with themselves older tools technology as well as add new flavors. So the first division we can say from early 2000 till around 2010, when RDBMS, Unix, ETL based systems served the need of building data warehouse and BI system. Oracle used to rule the world of databases. Informatica was the leader along with Ab Initio and later datastage for ETL processing. We used to build complex data warehouses by using some complex data models, mainly normalized form for enterprise data model and dimensional data models for datamarts, which was mean for specific needs of the consumers. ETL tools like Informatica would load nightly batch data into these data warehouses by converting different standard of data by applying very complex rules which was derived from the data models and the BI platforms. Business objects and cognos were leaders in the BI platform, and together with the ETL tool, they would form the data platform of any organization which generates complex reports and the analysis of the data, mainly the descriptive ones. ETL work tend to be extremely heavy as it was real hardcore technical job to load the data files successful in the system. In case of a problem with the data loading, it would take some real good brain to figure out the root cause of the problem. BI systems were relatively less technical, but these people were close to business and hence they would understand business requirements and had a lot of focus on aesthetics value of the reports and analysis. Overall, life was good and it went for more than 10 years. But then there were two major problems with these platforms. The solution of these problems provided a stepping stone for the technologies which would ultimately rule the data world for the next decade. The first problem was data performance. Company data was growing at a much faster rate. Data warehouse size is increasing year by year, queries speed getting slower, operational work getting complex. If any one of you have worked in Oracle or SQL Server, you would know they provide a lot of ways for improving the performance. Things like indexes, partitions, materialized views were all there actually. And there used to be a lot of query optimization techniques available. However, they were all limited by the overall server performance, and it was never an easy task to increase RAM and core after system is in place. I remember a table of some policy table for one of my project that had around 1 billion records, and the size of the table was around 1 terabyte itself. It would have some 30 plus different indexes created on different columns, and in spite of that, if I had to do just one plain count like select count one from the table name, it would take sufficient time in which I can go have coffee and come back. Big data world kids might be laughing at 1 billion 1 terabyte size of the table. They might think it's very less. Trust me, even today, if you don't do proper optimization of your data lake, it would be highly cumbersome and time taking for doing basic database operations. The other problem which was there in is everything had to be in some tabular format. Either it's table or the files should be having proper columns, either using some delimited or fixed space. In today's time, we call them structured data. So all these ETL and SQL tools can read and handle only the structured data, and no one had even thought of doing something with the semi-structured and unstructured data, as the capability was never seen by anyone. Informatica used to provide a way to handle XML files which was semi-structured in nature. However, it still needed its full definition in terms of XSD files, which eventually makes these structured only. The problem with unstructured data handling was not really big, as no one had handled these through data platforms, kind of unknowns to this area. However, when the solution of this problem of unstructured data handling along with the performance was handled by big data world, the entire industry moved to the different direction actually. Now, the problem of performance was really big. Loading data to normalized form in enterprise data warehouse and dimensional model into datamarts was never easy for anyone, and you needed a good support team to manage all. There were many initiatives being started in the market which was trying to handle this performance problems, and one big name came suddenly was Netezza. It was an independent company initially, and they would claim they were like 100 times faster than traditional Oracle based system in some scenarios. They would they used to have some high-end dedicated servers with many cores and RAMs, and together they would process the large amount of data in a newly defined architecture and producing data results in a faster way. The coffee time, which I mentioned before during the Oracle, query time, was really reduced to zero, as they were really very fast for many use cases. However, with complex SQL queries, the improvement was not 100 times, but still it was many times better. Netezza was later purchased by IBM for around $2 billion, and then started a new world of data platforms which was different from the traditional ones. Other than IBM Netezza, we now had different flavors from different vendors. Oracle had Exadata, EMC had Greenplum, SAP had HANA, SAP HANA, HP Vertica was there, Teradata Astrodata was there. Combined, these platforms are called MPP platforms, meaning massively parallel processing platform. They were successful in solving the initial problems of performance. However, in fact, their adoption was also very high. However, there were some new problems added now actually. They were damn costly, and you still have to pay for the ETL cost of Informatica and other things. Moreover, they were new, and hence some incompatibilities were there with the existing code and all actually. A lot of functions were not supported initially, and you had a lot of issues converting code from existing platform to the new platform. A lot of features takes a lot of time to develop, but it was mainly the cost which was really high. Still, things were going fine, and companies are either in the Oracle SQL Server kind of databases, or they are into MPP platform. The problem of unstructured data handling and the performance are still there because data is growing at unprecedented rate. To summarize, the first leg of data platform had databases like Oracle, SQL Server, Netezza, etc. ETL tools were Informatica and Ab initio and datastage. Data modeling was a third normalized form, and dimensional data model using Studio and Erwin used to be there. Reports and analytics used to be done using business objects and cognos. In terms of roles, we used to have a ETL developer, a report developer, business analyst for gathering requirements, data modeler, system admin, database administrator or DBA, designers who used to do the ETL column level mapping, etc. Solution architect and data architect roles were there, but not that prominent because there were very few defined patterns only. We didn't have a lot of variation that time. We used to get batch files in the night through some FTP mechanism to landing zone. Then a staging area is built on the database, and then finally data warehouse and enterprise data warehouse or data marts were built depending upon the vision of the organization and the analytical capabilities. So the second wave of data journey starts here when something called Hadoop and MapReduce was introduced from a different world and forced upon data world. Why I am saying they are forced? As because in data side, we never really had to do programming like Java and C and etc. We used to have complex query language, SQL, but they never had any overhead attached with that, which a developer had to do, and developer had to mainly focus on developing the logic and underlying complexity of running the query, optimizing the query, lies with the database and the ETL engine. However, the new world of MapReduce is a different game. HDFS was Hadoop distributed file system, which was a distributed file system on multiple commodity hardware, and the MapReduce written on Java was the language which supports data processing by adding code to its mapper and reducer classes. And who is going to do the coding now? That was a big question mark, as data people have never done the Java programming, and Java people have never seen large amount of mad data which tells its stories and problems only at the execution time. When the millions of data getting loaded in the night and solving the problems overnight is something not a week people can do actually. So somebody found a solution which was like Apache Hive came, that provided its own query language called Hive Query Language, HQL. And then someone wrote another platform called Pig that had another language for handling complex queries by breaking down into different variable assignments. That is called Pig Latin. They're now forming a new ecosystem called Big Data, and the name suggests they were for handling big data, which is large amount of data. So with the introduction of commodity hardware and the capabilities to handle unstructured data like complex XML, JSON, images, logs, videos, etc., the new use cases were introduced to the data platforms, and all the existing vendors started adopting these capabilities slowly. However, Hadoop world was leading all these developments with its unique file system, HDFS. New Apache-based open source libraries were introduced then. Things like HBase, Cassandra for databases, Hive MapReduce for data processing or ETL, Mahout for analytics and all actually. Cloudera became big name here, which tied together all the open source platforms and started distributing under their own packaging. Hortonworks and Mapper were two other vendors who would do the packaging of the open source platforms and were becoming key names. Overall cost of operation started getting low because of ability to process the data over commodity hardwares, which were cheaper in cost. However, resource cost started shooting up as these became very niche areas quickly, and we would need people who have worked in both the fields, which is data and Java. With the new ecosystem and new use cases, new problems started appearing, which was again performance optimization. Data is now growing at an exponential rate, and MapReduce based frameworks started becoming slow. New concept of data lake appeared, which is more about dumping everything the organization had to the lakes, totally different than the previous data warehouses, which is more about getting only a specific data needed by end users. New version of big data processing frameworks started coming into picture. There were things like Apache Tej, Impala, Yarn, Flink, Spark, Storm, etc. came in quick time, and it was getting very difficult to get hold of all these. Hortonworks was later purchased by Cloudera, and Cloudera became market leader in providing big data platform. It had Cloudera Manager for monitoring and deployment, HDFS for file storage, Yarn, Impala, Spark, Hive, Pig, Flink for data processing, Kafka, NiFi, Storm for real-time processing was there. Zeppelin and Hue for query writing, Ranger, Knox for data security, Atlas for metadata management. There's so many things which are out there actually, and one developer needs to know most of the things. New set of databases started growing for different use cases of data. They are called NoSQL databases. Hive, HBase, Cassandra, MongoDB, Couchbase, Redis, Neo4j, Elasticsearch, Solar. They are all part of this new journey actually. Things are really complex now. As a developer, we're supposed to know as many as tool possible with the ability to learn new things as soon as that product comes into existence. Soon after, Apache Spark became market leader because of its ability to process data quickly and its adoption to multiple languages. It can be written in Java, Scala, or Python. A Scala adoption was big, as a Scala was a very beautiful language and runs on the same Java JVM platform. However, as mentioned before, it was getting really hard to find good developers, as traditional database guys have never done any Java-based platform building, and most of their time gets stuck in platform level problems like setting up the IDE and at the Eclipse and then create jar files and all those things. So slowly Python picked up and overshadowed Java and Scala for any big data development, big data Spark development. Um, Mainly because a developer can now focus on the business logic more than handling its non-functional requirements of setting up the things and all. Actually, it was exactly the same scenario why PHP had overtaken the world in the web development side over Java or .NET, because a developer can focus straight to business logic without caring much of the other non-functional area. Python community were also becoming strong, and now it has become a language which can be used for almost everything in the big data world. Big data use cases are now streamlined, and many new architectural patterns are evolved. Few of them are Lambda architecture, hybrid architecture, data virtualization related patterns, and all those things. The second page of data evolution shows that moved out of traditional storage and the data structure, and now we have capabilities to handle any kind of data, either having humongous volume or variety, or which needs great performance. The base is now ready for the final page of data, which we now know. However, one thing to note is still most of the development is done using structured tables only for organization needs, and hence SQL is still undisputed leader here as well. ETL MPP vendors are still surviving here as well, as they have adopted some flavor of big data into their platform. In terms of BI systems, we now have advanced analytical platforms, where top-notch data scientists and machine learning experts are creating advanced analytical models using complex tools of TensorFlow and Keras. Reporting is being done by things like Tableau, Click, Power BI, etc. So in summary, the second phase data evolution means we have Cloudera, we have a Spark, we have Python, which is PySpark. In terms of roles, we now have data engineers in place of ETL developers. We have data scientists and also Cloudera administrator. Data modeling job is on the low now, as creating the art of beautiful data models is gone now actually. So the final page of data evolution is kind of scary now. If you have followed the journey till now, you should be able to understand with the stability in the underlying platform for data and its use cases. Now the focus is shifted towards non-functional requirements a lot, where we now have huge cloud adoption in terms of AWS, Azure. We now have automated code deployment using CI/CD mechanism through Jenkins and all. We now have infra as a code using Ansible and Terraform. And with this, a lot of info a data developers needs to know or to have the hands-on. Someone who would know just SQL till 10 years back now need to know how AWS works, along with this networking, load balancing, etc. How automated codes are written, how automated testing, even unit testing is done using things like JUnits and all. How to build a data product, which is quite different than creating data pipelines for individual tables. We now have to think and follow the cycle of a product development. One needs to understand how Docker and Kubernetes work. One needs to get exposure creating microservices and all the patterns attached with it, like event sourcing, CQRS, API gateway, etc. It's no easy for anyone to know a lot of these, and finding a right resource or training people are really cumbersome. Overall, this journey has taught us how to manage cloud based services like AWS Glue, Lambda, Redshift, EMR, Azure HD Insight, Data Factory, etc. Databricks and Snowflake are leading a lot of development in the data warehouse and big data platform over cloud, and one need to understand how they work as well. Without knowing the complexity of DevOps, CI/CD, Docker, Kubernetes, is very hard to think end to end. In terms of roles, we now need people with cloud and DevOps exposure. Solution architect and data architect roles have become very, very important as a lot of really complex solutions are being happening now over cloud, big data, and DevOps. This is all I had to cover to give you a quick walkthrough of the development around data which is happening in the data side for more than 2 decades. So you would understand the world where we are living now and what can be expected when we join a new project. Hope this helps. Thank you.